I'm so happy to be here. We will discuss this from two aspects. So first, I will look at the question of like fair sharing practices from the software perspective for like 20-ish minutes, and then Katie will take over and look at it more from the data perspective. But we will see that software and data go really hand in hand. I will try to keep it practical. Let's go to the next slide. Also, at the bottom of the slide, there is a short link that you can follow, and you can have the slide deck, but I will repeat it at the end. So then you can also save it and look at it later. First, one slide about me. So I come from chemistry. I did a few years in theoretical chemistry research. These days, I write research software and I teach programming to researchers, and I lead the Code Refinery project, where we teach things like this: fair practices, software licensing, open software. I work at the High Performance Computing Group, so I'm really interested in programming, computing, research software engineering group. I will repeat these links later, but I'm not a lawyer, so what I will say is not legal advice, but I will try to keep it really practical. So my goals for today is that I will try to connect software licenses to fair principles, but I will try to keep really practical recommendations for starting projects, contributing to projects, reusing other people's code, practical recommendations for individuals, for projects, group leads, with the goal of helping you navigating and deciding. What I will not try to do is, I will not try to find out which license is the best, because it really depends, but I will try to help you navigating it and deciding or remembering all the licenses or all the legal details. I will also not go so much into like ideological aspects of, I don't know, free software versus non-free software. We will try to keep it practical. Fair principles have probably been repeated many times. We will also see some different slide with fair principles. They are very important, not only in the data context, also in the software context. It's about keeping our output findable and accessible and interoperable and reusable. In my section, I will mostly look at the reusable part when we talk about licenses, but we will also see that they connect licenses, also connect to findability and to interoperability. But it will mostly be about the reusable aspect. I also really liked this overview here, which is from Heidi Seibold on good practices for reproducible research, 6 helpful steps. And these are the things we typically teach. It's a lot about how to organize a project, how to organize folders, how to document them, version control, compute environments. We will not talk about these things. I will focus on the number 6, publishing our code. But that's also the moment when it's typically a little bit too late to start thinking about licenses when we try to publish. It's good to think about it earlier, and I will motivate why. Let's go in there. Because at the beginning of a project, left panel, there is the empty field. It smells like spring. There is so many possibilities. We imagine all the code that we will write. That's often not the moment when we think about licenses. When I started my master thesis or PhD thesis, we didn't really talk about it. It didn't seem interesting or important. Let's talk about it later. But then this is also the moment when it's easy to set and easy to change. Later in the project, few years, fast forward, suddenly it's important, especially when we have combined projects or we have organization merge, we collaborate with industry, we collaborate with the public sector. Suddenly, licenses are difficult to change. And authors, they change affiliations, and things can get really complicated. And it's all about copyright. And copyright protects the creative expression. It's not the same thing as patent, and it's not the same thing as trademark. So patents are about ideas and trademarks are about names. Licenses, they are about copyright. And it's about the right to copy and a creative expression. And when we write software, we create its creative expression. It controls whether and how we can distribute software. And both original work, and I wonder whether you see if I highlight something maybe. So original work and the derivative work. And I think maybe useful names. So here on top right, we see some people copying a book because it's all started with books. But these days, I think we don't think so much about, the problem is not the copying. We download software from GitHub. The problem is we want to be able to change it and distribute the changes. So I like to think of it as distribute right or change right. Do I have the right to change things and share my changes? And any code we write is automatically protected by copyright, depending on the legislation, typically lifetime plus 70 years. So I challenge future generations 70 years after my life to even find my code and try to run it. So it will be tricky, new challenges, but everything is automatically copyrighted. The interesting question is, who has the copyright, though? We will come back to that. When you can take code from the internet and you can mix it any way you like. You can change it if it stays in your office, if it stays in your home, in the same way that I can take music records to my home and I can resample them and remix them. This is totally fine. It will start to be a problem once I start to, if I want to share it and sell the sample, the remixing. So I can do almost anything if I don't distribute it, but in open science, we want to distribute because we don't have the choice, because we are expected to publish software. Journals require this more and more, and I think for good reasons. Sharing software can also be a good insurance against being locked out of your own code, both for individuals and organizations. So we want to publish, and suddenly we need to be careful. Can I do derivative work? Can I make changes and share them? Now it matters to look at licenses. And here a little quiz for all of us. So a few questions that we can think about is, are these derivative work? So is this changing the code? Is this derivative work if I download a code from the website and I modify it? Yes or no? If I download some code from GitHub and I take one of the functions out and I use it in my own code, is this derivative code? Is this derivative work? What if you take something, you find a MATLAB code and you rewrite it completely into a different language? Now you rewrite it into C++ and it's unrecognizable. There is not a single line that is the same. Is this derivative work? How about linking to libraries? How about if you read a paper and you implement the algorithm? How about if somebody explains you the algorithm, but you never see the code? And well, it depends, but this is not legal advice. In practice, yes, downloading code, changing it is derivative work. Suddenly, licensing matters. I may or may not be allowed to do that. Taking something out of somebody else's code and putting it into my own code is derivative work. This one might be surprising. It surprised me, but taking a code, changing everything, different language, it's still derivative work. Linking to libraries is typically not. Also, implementing an algorithm is typically not derivative work. And this is, I think, central, knowing what is derivative work and what is not, because now we need to look at licenses and look at what, am I allowed to do this or not? And if not, then I don't even look at the original code because I can't publish the changes. All right, I have maybe not much more than 10 minutes left, but I wanted to give you an overview over the license types. I like to explain that with cakes because I think that's more relatable than legal text. But we will get a good overview of the different types, and later this will also connect nicely to the data licenses. And you can imagine that you have a cake recipe, and it's like a code. Code is recipes. You are the original author. It's really tasty. People like it. You share it on GitHub under the Open Cake organization, and then now suddenly, sooner or later, there is a famous restaurant. They find it on GitHub, but they want to suggest improvements. So the little, I don't know, strawberries are added to the cake, and they wish to put it on their menu. So they want to distribute this derivative work. Now, can they do that or not? And it depends, how have I licensed my recipe? If there is no license, or if I use a really custom license, then no restaurant chef will touch it because it's legally unclear. Maybe restaurant chefs will touch it, but at least no programming, no software company will touch it. But maybe they will bake it at home and try it and they never distribute the copies, and that is allowed. That is fair use. It's all about distribution. How about so-called permissive licenses? And here are 4 prominent examples: MIT, Apache, BSD. We don't have to remember them, but we at least when you hear these names, then you will know that these are permissive licenses. And there, people can do almost anything with it. They can modify it. They can share the modification. They don't have to share the modification. The only thing they have to do is they have to indicate where it came from. They cannot claim, if they distribute it, they cannot claim they invented it. They have to indicate where the original recipe came from, and maybe summarize the modifications. There is also a limit of liability. If somebody becomes sick, it's not my fault. And you have maybe seen these statements. This software is provided as is, warranty in uppercase letters. So that's the liability. So these are permissive licenses. Another class of licenses are share alike, copyleft. There is a weak version, weak copyleft. There is a strong copyleft version. 2 examples are the GNU lesser GPL and the Mozilla public license. The interesting thing about the share alike licenses is that if people distribute their changes, I have to be able to use their improved recipes. I have to be allowed to use their changes and improve them further. So they cannot, if they distribute the cake on their recipe, on their menu, they have to publish the improvements. And then there are some more technical details or differences between the Mozilla public license and the GNU's lesser GPL. And then there is a stronger version, the strong copyleft, and 2 examples are the GNU GPL and the GNU Affero GPL, where if this famous recipe a famous restaurant takes my recipe, puts it on the menu, they have to share the recipes of the entire menu. So that's the strong copyleft version. And a summary is that if there is no license, if it's custom, if it's proprietary, then derivative work is typically not possible. We cannot share it, and we will have to share it. So then, if we are not careful, we might get into a problem 5 years later. For the permissive licenses, if I look at it as an author, I may lose access to the derivative work. I don't have guaranteed access to the changes, but I have guaranteed access to the changes for the share alike licenses. And then there is the weak version, the strong version. And here you can look at it both from the perspective of the student, PhD, postdoc, code developer. You can also look at it from the perspective of, well, I'm a company, I want to now make changes based on somebody else's code. From the perspective of a company that has a lot of proprietary software, the permissive licenses will be more interesting than the strong copyleft one, because they put less restrictions on me. Good. I have not too many minutes left, but I want to talk about ownership. I think it is important. It is important to find out who owns the copyright for the software you write. And it depends on the country. It depends on the employer. It can get complicated. In the slide deck, I put some also, I have here some examples from UiT, here at Tromsø, but from different universities on links to more material, on recommendations, how they deal with ownership. And it is important because if you are the owner, You can decide about the license, you can change the license. If you don't, then you may need to contact the legal department at the university. What is important for open science and collaboration on GitHub, that once you accept contributions, pull requests, you may suddenly not be the only owner anymore. And then later, if you want to change the license, you may have to collect agreement from all the contributors. I want to list few, I promised that I would keep it practical. So what practical recommendations I can give to when you start a new project, but also before starting, what about an existing project? So when you start a new project, then license your code very early, because at the beginning it was easy. You cannot ignore licensing. Often when I start with something new, I start with a README, I start with a license file. It's nice to have a little bit more than just these two. Even before starting, it's good to discuss this. It can be good to put this on the proposal, to find agreement among all the project partners. When you choose a license, don't design your own, take a standard one. One of the licenses that have been mentioned, because then compatibility has been already clarified by somebody. If you design your own, then compatibility is not clear. When you contribute to somebody else's code, think about licenses as well, because you don't want to lock yourself out of your own code. There is one project, there is one code that I have written 3 times from scratch because of license reasons. I didn't have access to my own code. I had to do it from scratch again, and then yet again. So I got really burned by this. And these days, before I embark on anything, I clarify the license. If you receive contributions, you get a pull request, 20,000 lines of code. It can be good to clarify where did this come from? What is the license of it? One very good recommendations I got was work as if the repository is public, even though it is not yet public. Maybe you want to make it public in 5 years, but you don't want then to go through all the history and remove the problematic parts. It's really to avoid surprises about code in the history that doesn't belong there with incompatible licenses. And later you need to do cleanup. And I've been through this in a couple of projects. And I think this is one more practical recommendation slide. How about you have an existing project, but now you want to open source it, or you want to decide one of these standard licenses? Clarify ownership. You may need to identify all contributors, and all of them need to agree. And if somebody disagrees, then you need to go into the history and take their contribution out. There are tools that can help modifying history. In any legal dispute, the first thing people will look at is the code history. If you have a code that has no history at all, it can look a little bit suspicious. So that's another reason to use version control. Let me see what else do I have, and I will not go through everything. I want to highlight the important things. I will skip this for the sake of time. We will connect to data licenses in a moment. Maybe I wanted to point out the differences. What is different about software licenses and data licenses? In data licenses, we will see that there exist non-licenses that don't allow you to make derivative work. That doesn't really exist in software, as far as I know. Also, the restriction of non-commercial. So that is something that the Creative Commons licenses have. But there can be restrictions on usage in terms of ethical use. And here I refer to a resource to read more about that. I will not go more into detail. Finally, I know that this group is working a lot on machine learning AI. I have in my presentation, many of the images that I have used have been generated by generative AI. It was just for like my own fun. It was fun to experiment with it. But now we enter a new age where we have machine learning models, AI. Is it data? Is it software? I don't know. But now suddenly we need to consider the AI solution, the training data, the production data, the AI output, the AI evolutions. And we need to think about licenses. We need to think about ethics and liability. What if the model predicts that it detects cancer in one case, it doesn't in the other one? somebody gets harmed, who is liable now? And I'm not an expert in this field, but I list here a couple of resources where one can read more. I think it's a very interesting question. Maybe we can come back to that during the Q&A. I will skip these 2 slides and come to my final slide. There is the link to this slide deck. So bit.ly/practical software licensing. The 2 projects where I work on these days a lot, and please explore, please use us, Code Refinery and Resource Software group at UiT. We would love to discuss these more and help out. And I also link to more resources, books, articles, blogs about licenses and software citation. I didn't really discuss software citation for the sake of time. And I think I will hand over the microphone to Katie, and looking forward to, or to the chair, and then looking forward to discuss later your questions.
Okay, so my name is Katie Smart, and I'm from the University Library. My background is in geology, and I work in the Research Data Management Group, as well as I am the contact point for computer science and physics. So I'm going to follow on from Radovan's presentation about talking about good practices for sharing your research data in a fair way. And hopefully we'll discuss a bit more about licenses towards the end of this presentation. So I wanted to start about outlining what fair data is and what the FAIR principles are. The FAIR principles, FAIR data, was born out of the recognition 2014, 2015, 2016, that not all research data is effectively and fairly preserved. And there was a research paper, and I think it was 2016, in Nature Data, outlining the principles for how to make all research data fair, ensuring its long-term preservation and access. And this paper then evolved into a movement, the FAIR data movement, that promotes preserving research data in an open manner with easy access and for long-term reuse. So FAIR data is really a part of open science, which is a great thing for ensuring that our research data products are effectively reused in the long term, and good to promote open science in general. So in detail, what are the FAIR principles? So the F in FAIR is findable, and that basically means that your data should be easy to find for humans. So you and I, if we do a search in Google, for instance, we can find the data, but also for computers. And that means that any research data should be published with a persistent identifier. And your data also is equipped with a lot of metadata, which means it can be easily found. And the data should be indexed in search engines. So if I want to find it, I can find it. Or if you've trained a machine to find it, the machine can find it. The A in FAIR is accessible. So now you've found the data, or the computer has found the data that you're looking for. But once you've found it, you can access it. So there's a well-defined and open protocol on how to access the data. And some data you may not be able to archive it or store it openly. You may contain some sensitive data, some person identifying data, some data that can't be made openly available for a variety of reasons. So that your data may actually require some authentication authorization. But in the A in accessible means there is a protocol, a clearly defined protocol on how you can actually access that data. So even though the data is not open, it's still fair because you know how to access it. The I in FAIR is interoperable, and that means the data that you are archiving must have the ability to be integrated into other data and incorporated to an existing workflows. And that means that you're using open and standardized metadata formats and maybe controlled vocabularies. Basically, you're comparing apples to apples. You're using the same terminology within your community of practice. That means your data can be easily used with other data. And then finally, R is reusable. And the ultimate goal of FAIR data is really the reuse of data. So having data reused over and over again into new projects, maybe being used in different ways. And so that means the data that you're archiving needs to be adequately described and where the provenance has been clearly shown. And there's several different steps to making your data reusable here. One is that your data is documented. And you can do that firstly through metadata, but also you provide something called a README file that Radovan showed earlier. And the README file is, I'll show you what that is in just a second. But basically, it's like a roadmap or a recipe for a user to know why the data was generated, how was it generated, how was it modified, how is it processed, and how should you, the reuser, use it. So that's a very important part of being reusable. Another part about having your data being reusable is that you've preserved your data in an open, non-proprietary format so that anyone can take the data and can use it even if they don't have the same kind of software that you use to create the data, for instance. And finally, which is very important, which Radovan very nicely outlined, is that data are equipped with a clear use license. So you must license your data so that other people and computers also know exactly if they're allowed to use the data and if there's any restrictions on how they can use the data. So licenses are extremely important in the FAIR data process. So then why should you use FAIR data? Well, I mean, you should want to make your data fair because it promotes open science and it ensures reuse of your data, which is what we all want. But if you work at UiT, for instance, then you sort of have to make your data fair. So there is a requirement from 2017 onwards that all projects going forward have to openly share research data as much as they can. So you should share your data openly for reuse as long as there are no considerations that might limit you. So maybe you have some legal, ethical, security, commercial reasons why you cannot make your data openly available. And so, for instance, if you're using person identifying data or perhaps medical records from people, you may not be able to openly share your data, but there are avenues where you can perhaps archive metadata, or perhaps you need to archive the data on a repository that's got some access control, like the NSD. Irregardless, the research data must be made available in some form as early as possible. I mean, generally, if you publish a manuscript, you should be thinking about making the data fair at that same time. And it's important when you're creating a project and starting a project, as you should be creating a data management plan at the same time that goes through how are you going to accomplish this task of making your research data openly available and fair. But moreover than UiT's requirement, there is a movement among major funding agencies to make your data, to promote open science and make research data fair. So if you're funded by the RCN, they have a policy to make your data as open as possible and as closed as necessary if you have any type of sensitive data, for instance. And furthermore, if you receive funding from the EU, like Horizon EU, they have the same policy. So if you receive funding for your research project from these major funders, you are tasked with making your research data open and fair. And it goes further than that. It's not just about uploading your data somewhere to some repository. It's also to make sure that the research data is managed and curated to reveal its full potential. So you don't want to just do a data dump. You want to make sure that your data is documented and organized in a good way within the best practices within your community. And so that's something we at the library can assist you with to make sure that your data is properly managed and curated so that it forms a really nice data package that's easily reusable in the future. Okay, so here's the practical part and how, you've got some data. Now, how can I make my data fair? And on the right-hand side is a graphic that we commonly use here at the library that shows the life cycle of a research project. Starting at the beginning, when you sort of formulate the research question, you write your data, you see what other data is out there, you write a data management plan, more to the active phase where you start actually collecting data and storing data, and to the publication phase where you want to start sharing your data openly. So during the entire life cycle of a project, it's really important that you document your data, and that's part of making your data fair. So this includes keeping track of methodologies that you use to create and modify your data, code descriptions, making sure you keep a good record in your lab notebooks, recording experimental protocols, and basically the provenance information for the data. And there's sort of two levels of data documentation. One is the project level documentation. So that is sort of more on a wider scale. It can include when and where the study occurred, who collected the data, what quality assurance or standard measures were run to ensure that your data is of good quality. And on the data level documentation side, this could include what kind of data you were collecting, how the data is structured into file folders, how the data was processed. This is sort of more of the nitty-gritty details, but is important to document to understand the provenance of your data. And so for humans, this kind of documentation boils down to the README file, which is the roadmap for future users to understand why the data was generated, how it was modified or processed, and how you can use it in the future. So the README file is a good document to begin early in the project and can update it continuously throughout the project. And obviously you're going to want to store it in an open format like a text file so that we're not worrying about it being stored in a proprietary file format. So here is an example of a README file. So I've taken a data set that was archived on DataverseNO, which is UiT's open repository, and it was taken from a couple of years ago. And here, so on the left-hand side, you see the citation for the data set. And on the right-hand side, I'm just going to play a video that shows you the README file for this particular data set. And this is an extremely detailed README file. So there's a lot of information here. So at the top, you'll see general information like the title of the data set, the persistent identifier, the DOI. You'll see the name of the person who generated the data set. There's a very detailed methodology here showing how the data was generated. In this case, it's code. And then there's a good overview showing the file structure and the folder structure that the code and the data has been stored into, with lots of description. Then they have even more information about specific files. So this person has done a very nice job in documenting the data. And as we get towards the bottom, you'll see there's some information telling you where you can find the license on how to reuse this data. So this is an extremely detailed README file, but if you wanted to reuse this data, you'd have a very clear picture from this detailed README file on how this data was generated and modified and how you are allowed to reuse it in the future. So that's a very nice example of a README file. So that's one type of documentation. The second type of documentation that's extremely important is providing a rich metadata to your to your project. So metadata is really data just about your data, but it's primarily used by machines to find your data. And so the more complete or the richer your metadata is, the easier it is for a computer or something to find your data set. So more metadata, more findable. Metadata can sort of be grouped into three different levels. There's administrative metadata, which again is sort of top-level metadata, and that's relevant for the management of the project. So who is the PI? What is the identification number of the grant that we used to fund the study? Are there collaborators? What was the time period the study was conducted on? The second type would be descriptive, and this is sort of more relevant for the discovery of your data set. So what is the title of the data set? Who are the authors? What are the keywords? The DOI, the abstract perhaps for the data set. And then we have structural metadata, and this is more for about how the data came about and what the internal structure is of the data. So you would describe the variables used, the units, sample sizes, sampling methods, sort of the finer information on the data. And here we'll talk about in just a second, but this is something where if you can, you want to use a subject-specific control vocabulary to describe the data. And I'll show you an example of that in just a second. So again, we go back to this data set once again, and now I'm going to show you a short video on the metadata for this study to show you the kinds of things that you would expect to provide to make your data very findable. So we'll scroll down again into the metadata, and here you'll see things like the persistent identifier, the title of the data set, the authors, a good description, subjects, keywords, when the data set was created. And at the bottom, there's some very specific structural metadata that give you the specific types of data and variables that were considered in this data set. So that's the kind of metadata that you should be thinking about providing for any data set. It's really not very difficult. It's fairly straightforward, but it's the more metadata and the richer it is, the better it will be for people to find and reuse the data set. And so I mentioned using control vocabularies when appropriate. So for some subjects, there are discipline-specific metadata standards and control vocabularies. A good example of this is in the life sciences, the MESH, the medical subject headings, which you can find through looking at the National Library of Medicine. And these provide a specific vocabulary to describe topics or factors within the life sciences. So if you assign these control vocabularies, then it makes it really much easier to make your data more machine readable. to basically connect apples to apples when trying to interoperate data sets with one another. So here I've taken the keywords from that previous data set. I did not mean to do that. And here you can see that they have two keywords that are taken from the mesh library. And this is really great because that means that if someone or something is trying to do a search on one of these two factors like TIL, then this data set would be connected into that search, that searching. So control vocabularies are if you have one, and not every subject area has one, they're very effective to assign as rich metadata to your study. Okay, so now you've documented your data. So both humans and machines know how to find and reuse your data set. Now you need to make it accessible. So you must ensure your data has a persistent identifier. If you publish your data set in a publication or you archive it in a repository, a trusted repository, you'll get a DOI and you don't really have to worry about that any further. You may need to implement some access control. So perhaps your data contains some sensitive information, some person identifying information. You may need to anonymize your data set before sharing it openly, if possible. But if you have sensitive data that needs some access control, you need to put it somewhere where it can have access control or authorization. So for instance, the NSD. Even if your project contains sensitive data, possibly you can still share the metadata openly, but every case is different. And the last thing you need to do for access is make sure that you have stored your data in an open file format and for long-term preservation. So you want to use non-proprietary file formats when you're archiving or publishing. That means that users who use different operating systems or softwares can use your data and they're not hampered by that. There's detailed lists on what preferred file formats are for archiving openly. And we have one for the DataverseNO, which I've linked to right here. And when in doubt, you could ask a data curator who'd be able to help you figure out if your file format is acceptable or not. Okay, licensing. So Radovan went into this in a lot of detail, and I'm not going to go into this in too much more detail. So generally speaking, if you want to maximize reuse of your data, you really want to use the most open license that you can. And it's really important that you actually do equip a license to your data. If you don't equip a license to your data set, you're effectively reserving your rights and you're saying people can't reuse your data, which is probably not what you're going for. So for data licenses, the most common types are the Creative Commons or the CC licenses. They're free of charge, they're easy to use, and they're really widely recognized. And that's an easy way to grant permissions or tell people how they can reuse your work. And the most open license there is the CC0 license that maximizes reuse. So you can use a CC license, and that basically enables anybody to take your data and reuse it in any way they want. And if usually and under normal ethical research practices, people will obviously give credit to you, to your data. So you'll often see also on academic publications, you might see a CC BY, which basically means you have to give attribution. So you can reuse the work, but you must, reference the work the previous work. However, we really recommend people to use the CC0 if possible, because that maximizes its reuse. And usually people are very scrupulous and ethical, and they will obviously reference any data sets they use in their new work. The difficulty comes in, of course, when we have data sets containing code and software. And rather than you should be looking to more software-specific licenses that Radovan outlined, because they are widely recognized in their field, and they address more specifically derivative works and distribution. So Radovan already outlined great resources, and the ones that we've looked at a lot are the Open Source Initiative, as well as the Choose a License, which is a nice way to get started. And so oftentimes here at the library, when we get data sets that contain code, sometimes it's a mix of both code and data, and that becomes trickier to figure out what kind of license to choose. And we can help you on a case-by-case basis if need be. And so next, I actually want to go over to how to share your data and talk about DataverseNO in a little bit more detail. So by now, you've made your data fair. You've ticked all the boxes. Everything is documented. You've got access or access control if you need it. You've got a license. You're ready to go. So how do you share your fair data? You could publish open access with all the data available. All right, that would be one way. Or in addition, you could choose a trusted repository. There are lots of repositories out there. So if you're questioning which one to use, you could use re3data.org to find a repository that's useful for you and your subject. But whenever you choose a repository, you should look for one that's got this core trust seal symbol, which means that repository or database has been vetted, so to speak. It's undergone, I forget how many steps. There's like 16 steps to say that this is a good repository. It's going to ensure long-term preservation of your work, and it's curated. So you can also use the DataverseNO, UiT Open Research Data on DataverseNO, which is UiT's open repository, and it has the core trust seal symbol, and it's been verified. It's part of the global DataverseNO family, and so obviously any data set here will get a DOI, it'll be indexed in search engines, and we're going to curate, and all data sets here will have a nice rich metadata. So now I just want to briefly walk through two different data sets on DataverseNO, which have different licenses applied to them. So this is the data set we've seen now several times, and I'll just show you what the data sets look like. It's another video. So here you see the data set, the description. You can see all the data sets have files in persistent formats. Some data sets have a lot of files, some don't have so many. We've already looked at the metadata, but here it is again, one more time. A nice rich metadata means the data set is very findable. And then we're going to go and next look at the license. Oh, but this one has got particular life science metadata as well. But next is the terms, which contain the license. And in this case, this data set has chosen a CC0 public domain license, which means that you can take this data set and reuse it. Obviously, you're going to give attribution because you're an ethical researcher, but this means this data set can be easily reused. And there's sort of, it's a nice way to license your work to maximize reuse. The next data set I want to look at is also in the informatics sphere. And this data set is a little bit different. It contains quite a lot of code again. So if we look at the files, here we go. This data set contains both data as video files, but it also contains quite a lot of coding language as well. So it's sort of hybrid in that sense, which made it a little bit tricky in this way to figure out what kind of license to have. Again, we have metadata, which the person has provided lots of nice rich metadata. But when we get to the terms, you're going to see that there is a different type of license applied. So in this case, for this, so that here they tell you what kind of software they've used. In this case, this license has a custom license, well, not a custom license, but it doesn't have the CC0 license. In this case, the person has applied an MIT license because the data set was based on derived code, if I remember correctly. And that original code had an MIT license applied. So they've done the right thing. They've made a derivative work and applied the same license. So DataverseNO can accommodate either type. It just depends on you and what your data set requires. If you have further questions on research data management, like how to make your data fair, we have a nice data portal where you can learn lots about this subject. And if you have a question, you can send an email to the researchdata@yelp.uit.no, and we'll help you with whatever your concern might be. And then finally, I'd outline that the library runs courses every spring and fall, and they're in Norwegian and English. I think this is the Norwegian file list, yes. And it starts up next month, so you can register for any of one of these courses if you need to learn more. And my name again is Katie Smart, and you can email me directly with questions, or also, again, the researchdata@yelp.uit.no if you have any questions about what we talked about today. And that's all I have for you.